There's a strange thing about growing up. As a child, you were constantly doing something that felt completely natural, almost automatic. No one had to teach you how to do it. In fact, it was nearly impossible for you not to do it. You didn't even realize it was a skill. It just felt like the default way of being alive. You didn't just look at the world, you examined it. You explored it in a raw, unfiltered way. When you picked up an object, you didn't immediately assign it a purpose and move on. You stayed with it. You turned it around in your hands, noticed its weight, its texture, the way light moved across its surface. You dropped it, not out of carelessness, but curiosity. You wanted to see what would happen. A spoon wasn't just something to eat with. It was something reflective, something that could distort your face. You might have tilted it slowly, watching how your reflection stretched and flipped. You may not have had the words for it, but you were observing something real, how surfaces interact with light, how angles change perception. And the important part is this: you weren't trying to reach a conclusion. You weren't thinking in terms of right answers or wrong answers. You were fully engaged in the process of noticing. At that stage, the world didn't feel obvious. It felt strange, open, and full of unanswered questions. Even the simplest things carried a kind of mystery. Why does this feel cold? Why does that make a sound? Why does this object behave differently when I push it versus when I drop it? These weren't formal questions. They didn't need to be spoken. They were embedded in your attention itself. But slowly, something began to change. You started learning what things are called. You were told, this is a spoon, this is metal, this is reflection. And while those labels were useful, they did something subtle to your way of seeing. Once something had a name, it began to feel understood. The moment you could identify an object, your brain stopped investigating it. The label acted like a full stop. Instead of continuing to observe, you moved on. The curiosity that once kept you engaged started to fade, not because the world became less interesting, but because it became more familiar. Familiarity creates an illusion. It makes complex things feel simple. Even when they're not, when you see a common object now, your brain processes it almost instantly and tells you, you already know this, and that's the end of it. But if you pause, even for a few seconds, and really look again, something unusual happens. The simplicity begins to break apart. That ordinary object starts to feel slightly unfamiliar again. You notice details you usually ignore. You realize you don't actually understand it as completely as you thought. This shift is small, but it's important. Because what changed over time wasn't the world. The same patterns, the same physical processes, the same underlying reality is still there. What changed is how you relate to it. As a child, you were comfortable staying inside a question. You didn't rush to close it. You didn't need a final answer to feel satisfied. The act of observing was enough. As you grew older, you were trained quietly, consistently, to move faster, to recognize, label, and proceed, to treat understanding as something that can be completed quickly. And without noticing it, you stopped doing the one thing that made the world feel alive and deeply real. You stopped looking closely enough for things to become strange again. At some point, you began collecting explanations, not deep explanations, but quick ones, efficient ones. The kind that allow you to move on without slowing down. Someone tells you, this is reflection, and it feels like the question is finished. Light hits a surface and bounces back. That's the explanation. But if you pause for a moment, something feels incomplete. What does it mean for light to bounce? What is light exactly? Why does it behave that way? Why should a surface change the direction of something invisible in such a precise and predictable manner? The explanation you were given works, but only at a certain level. It describes the behavior without really uncovering the deeper mechanism. And yet, your brain accepts it as sufficient. This is where something subtle happens. The label replaces the curiosity. As Richard Feynman often emphasized, knowing the name of something gives a false sense of understanding. If you say, this is electromagnetic force, it sounds impressive, it sounds complete. But if someone asks you what that force actually is, in a fundamental sense, you quickly realize the answer becomes less clear. You can describe how it behaves. You can write equations. You can predict outcomes with incredible precision. But when it comes to explaining what it is, you start circling back to definitions that rely on other definitions. It becomes a loop. And instead of recognizing that loop, most of us step out of it by accepting the first explanation that feels stable enough. This is not a failure of intelligence. It's a feature of how the mind works. The brain prefers closure. Open questions take energy. They create a kind of tension and unfinished feeling. So when an answer is offered, even a partial one, the brain relaxes. It marks the problem as solved and shifts attention elsewhere. As a child, you didn't do this as quickly. You could hear an explanation and still remain unsatisfied, not in a frustrated way, but in a curious way. You would keep looking, keep noticing, as if the answer hadn't fully landed. But over time, you learn to treat explanations as endpoints. You were rewarded for it. In school, the goal is often to arrive at the correct answer as efficiently as possible. There's rarely time to sit with a question once it's been labeled and categorized. The system encourages completion, not exploration. So your thinking adapted. You became faster at recognizing patterns, faster at applying known ideas, faster at concluding. And this speed is useful. It allows you to function in a complex world without getting stuck on every small detail. But there's a trade-off. Speed reduces depth. When you move quickly from question to answer, you skip over the part where understanding actually deepens. You accept the surface and move on before the underlying mystery has a chance to reveal itself. And the strange thing is, this happens even in areas where we know the explanations are incomplete. Take something as basic as why objects fall. You might say, because of gravity. But what is gravity? You can say it's the curvature of space-time or a force between masses. Both descriptions are useful. Both are supported by evidence, but neither fully answers the deeper question of why such a phenomenon exists at all. At some point, every explanation reaches a boundary. Beyond that boundary, we don't have clear answers. We have models, approximations, and theories that work extremely well but don't eliminate the mystery. As children, we naturally push toward that boundary. As adults, we tend to stop just before it, not because we can't go further, but because we've learned that going further doesn't always produce neat, satisfying conclusions. So we settle into a comfortable illusion that we understand more than we actually do. And that illusion is built quietly and consistently out of names. Take something that feels completely obvious, something so familiar you never question it. Touch. Right now, if you place your hand on a table, it feels direct and undeniable. Your skin presses against a solid surface. There's resistance. There's pressure. It seems like the most basic form of contact you can imagine, but if you slow down and look beneath that experience, the picture begins to change in a surprising way. Your hand is made of atoms. The table is made of atoms. Each atom has a nucleus surrounded by electrons. And those electrons occupy regions of space that don't have hard edges like tiny solid spheres. They're better described as probability clouds, regions where an electron is likely to be found. Now, when your hand touches the table, what actually happens is not two solid objects meeting. Instead, the electron clouds in your hand come extremely close to the electron clouds in the table. And when they do, they repel each other due to electromagnetic interactions. That repulsion is what creates the sensation of pressure. So what you feel as solid contact is actually a kind of invisible standoff. The particles never truly merge or overlap in the way your intuition suggests. There's always a tiny gap maintained by these forces. This leads to a strange conclusion. What you experience as touch is not contact in the classical sense. It's the effect of forces acting at incredibly small distances. As a child, encountering an idea like this would feel almost magical. It would raise more questions than it answers. If nothing really touches, then what does solid mean? What does it mean to hold something or to feel it? But as an adult, there's a tendency to accept this explanation quickly and move on. You might say, okay, it's electromagnetic force, and leave it there. But if you stay with the question, it opens up further. What is this force really? Why do charged particles repel or attract each other? Why should the presence of an electron influence another electron across space? Physics gives you a framework. It describes fields, regions where forces can act. It gives you equations that predict how these interactions behave, and those predictions are incredibly accurate. They allow us to build technology, to understand materials, to manipulate the physical world in precise ways. But the deeper question, what a field actually is, why it exists, why it has the properties it does, remains less clear. At that level, the explanation becomes more abstract. And this is where many people quietly disengage, not because the topic is uninteresting, but because it becomes difficult to visualize. The mind prefers concrete images, things you can picture clearly, but at the fundamental level, reality doesn't always offer that kind of clarity. Instead, it offers relationships, patterns, and behaviors that are best expressed mathematically rather than visually. As a child, you didn't need a complete picture to stay engaged. The mystery itself was enough. You could hold a question in your mind without resolving it, without needing it to become simple. But over time, you learn to associate understanding with clarity and closure. If something couldn't be easily pictured or explained in simple terms, it started to feel less accessible, less worth pursuing. So you began to accept simplified versions of reality, the kind that fit neatly into everyday experience. Objects are solid, contact is direct, surfaces are continuous. These ideas are useful. They allow you to navigate the world efficiently. But they are approximations, not complete descriptions. And if you pause long enough to look again, even something as ordinary as placing your hand on a table begins to feel unfamiliar. Not because it changed, but because you're seeing it with a deeper question in mind. And that question doesn't close easily. It expands. If you keep following this line of questioning, if you don't stop at the first satisfying explanation, you begin to notice a pattern. The deeper you go into the structure of reality, the less it resembles the solid, intuitive world you experience every day. Start again with something simple, your own body. It feels continuous, stable, clearly defined. Your hand looks like a solid object with a clear boundary. But when you begin to examine what it's made of, that clarity starts to dissolve. Your body is made of cells. Each cell is made of molecules, complex arrangements of atoms bound together in specific ways. Those atoms themselves are mostly empty space, a tiny nucleus at the center, surrounded by electrons that don't orbit like planets, but exist in spread out regions of probability. If you could zoom in far enough, the idea of a solid object would disappear completely. You wouldn't see a smooth surface. You'd see vast gaps with particles interacting across space through forces. And if you go deeper still, even the idea of particles becomes less straightforward. Electrons, for example, are not tiny balls sitting in a fixed place. They behave like both particles and waves, depending on how you observe them. In some experiments, they act like localized points. In others, they spread out like ripples. So what are they really? The honest answer is that we don't have a simple picture. We have mathematical descriptions that work extremely well. We can predict outcomes with incredible accuracy. But if you try to imagine what an electron is in a concrete, everyday sense, the image breaks down. The same thing happens as you look deeper into protons and neutrons. Inside them are quarks interacting through forces that are even less intuitive. And beyond that, modern physics suggests underlying fields, continuous entities that exist throughout space, where what we call particles are just excitations or disturbances. At that level, reality is not made of solid objects at all. It's made of patterns, interactions, and relationships. And this is where the discomfort begins, because your brain is built to understand objects, things with boundaries, shapes, and locations. But the fundamental structure of reality doesn't fully match that model. So there's a gap. On one side, you have direct experience, a world of solid things, clear edges, and stable forms. On the other side, you have deeper descriptions that replace those solids with probabilities, fields, and interactions. Both are valid in their own contexts, but they don't fit together neatly. As a child, encountering this mismatch wouldn't necessarily bother you. You could sit with the confusion, explore it, let it remain unresolved. The tension between what you see and what might be happening underneath would feel like an open space to explore. As an adult, that same tension often feels like a problem to fix. You want a clean, unified picture, something that makes intuitive sense. And when that's not available, there's a tendency to retreat to the simpler model, the one that feels stable and familiar. Objects are solid. Things are where they appear to be. Causes lead directly to effects. These ideas work well enough for everyday life, so you rely on them. But beneath that surface, reality continues to operate in ways that are far less obvious. And the more seriously you take that fact, the more you realize something important. Understanding does not always mean forming a clear mental image. Sometimes, understanding means accepting that the best descriptions we have are abstract, incomplete, and resistant to intuition. This is not a limitation of effort. It's a reflection of how reality seems to be structured at its deepest levels. And recognizing that doesn't close the question. It opens it further. There's another layer to this that is easy to miss because it doesn't come from physics directly. It comes from how your mind interacts with everything you perceive. You don't experience reality as it is. You experience a constructed version of it. This is not a philosophical claim in the abstract sense. It's something grounded in how the brain processes information. Your senses are constantly receiving signals, light hitting your eyes, vibrations reaching your ears, chemical interactions on your tongue and in your nose, pressure on your skin. But these signals are incomplete, noisy, and fragmented. Your brain takes all of this and builds a coherent picture. It fills gaps, it smooths edges. It creates continuity where there might only be scattered data. What you see as a stable, detailed world is actually the result of continuous interpretation. And most of the time, you're not aware that this is happening. You feel like you're directly observing reality, but what you're really experiencing is the brain's best model of it. As a child, this model is still forming. You're not fully committed to it yet. That's why things feel more vivid, more surprising. You notice inconsistencies more easily. You question things that don't quite fit because your expectations are not as rigid. But over time, the model becomes stronger, it becomes efficient. And efficiency comes at a cost. Instead of analyzing every detail, your brain starts predicting what should be there. It uses past experience to fill in the present. If you see a familiar object, your brain doesn't process every feature from scratch. It recognizes the pattern and completes the image automatically. This is incredibly useful. It allows you to move through the world quickly without being overwhelmed by raw sensory input. But it also means you stop seeing what's actually in front of you. You start seeing what you expect to see. A simple example is reading. When you look at a sentence, you don't analyze each letter individually. Your brain recognizes whole words, sometimes even skipping over errors without noticing them. The meaning arrives before the details are fully processed. The same thing happens with objects, faces, environments. You're not carefully observing them, you're recognizing them. And recognition is not the same as observation. Recognition is fast, automatic and shallow. Observation is slower, deliberate, and deeper. As a child, you spent more time observing. As an adult, you rely more on recognition. This shift changes your relationship with reality in a fundamental way. Because once recognition takes over, the world becomes predictable, familiar, stable. But that stability is partly an illusion. It's maintained by the brain's ability to ignore variations, to filter out what doesn't fit the expected pattern. If something moves slightly, changes subtly, behaves in an unusual way, your brain often adjusts the perception to keep things consistent. Only when the difference becomes large enough does it break through into awareness. This means that a lot of what is actually happening never reaches your conscious experience. You live inside a simplified version of reality that is optimized for action, not for deep understanding. And this connects directly to the habit you lost. As a child, you were less bound by these predictions. You were more open to raw perception, more willing to notice small details, more sensitive to things that didn't quite make sense. You hadn't fully learned what to ignore. So you saw more, not in terms of information, But in terms of attention, you allowed things to be unfamiliar. As you grew older, you learned to filter aggressively. You learned what matters, what can be skipped, and that made life easier, but it also made reality feel more obvious than it really is. If you slow down and look carefully, you can still catch glimpses of this process. Moments where something familiar suddenly feels slightly off. Moments where you notice a detail you've passed 100 times without seeing. Moments where the world doesn't fully match your expectations. Those moments are small, but they reveal something important. The world you experience is not just out there. It's something your mind is constantly building. And once you see that, even briefly, the idea of simply looking at something becomes much more complex. Because now the question isn't just what you're seeing. It's how much of it is really there, and how much of it is being quietly filled in. Now consider something even more subtle than objects, forces, or perception. Consider boundaries. You move through the world as if everything has clear edges. A table ends where the air begins. Your body ends at your skin. One object is separate from another. This seems so obvious that it rarely feels worth questioning. But if you slow down and examine it carefully, the idea of a boundary becomes much less precise. Take your hand, for example. You can see where it ends. You can trace the outline of your fingers and say, this is me, and everything beyond that is not me. It feels definite. But at a microscopic level, that boundary is not a sharp line. The atoms in your skin are not forming a perfectly solid wall. They are in constant motion, vibrating, interacting. The outermost electrons extend into space, overlapping and interacting with the molecules in the air around you. There is no exact point where your body stops and the environment begins. There is a region, a gradient of interactions. Even more, your body is not static. With every breath, you take in air, oxygen molecules that become part of your bloodstream. With every exhale, you release carbon dioxide that was part of you moments ago. Tiny particles are constantly leaving your skin. New material is constantly being incorporated. From a physical perspective, you are not a fixed object. You are a process. A continuous exchange of matter and energy with your surroundings. So if the material that makes you up is constantly changing, and the boundary between you and the environment is not sharply defined, then what exactly is the you that feels so stable? This question doesn't have a simple answer. In everyday life, the idea of a clear boundary is extremely useful. It allows you to act, to navigate, to make decisions quickly. You don't need to think about molecular exchanges to pick up a glass or walk through a room. But usefulness is not the same as accuracy. At a deeper level, the separation between things becomes less absolute. Even something as simple as a cup sitting on a table is not entirely separate from it. The atoms in the cup interact with the atoms in the table. Forces pass between them. Energy is transferred. On a fundamental level, everything is part of an interconnected system, and this extends further. The air in the room interacts with the walls with the ground with the rest of the planet. The planet itself is interacting with the gravitational field of the sun, which is interacting with the rest of the galaxy. What appears as separate objects are, in a deeper sense, regions within a continuous network of interactions. As a child, you might have sensed this in a vague way, not as a formal idea, but as a feeling that the world was less rigid, less divided than it appeared. You might have asked questions that didn't fit neatly into categories. Questions like, where does something really begin? Where does it end? How do we know that two things are truly separate? These questions don't have clean, final answers. And because they don't, they tend to be set aside. As you grow older, you learn to rely on clear distinctions. This is me, that is not me. This is the object, that is the background. This is where it starts, that is where it stops. These distinctions are practical, but they are also simplifications. If you look closely enough, the edges begin to blur. And when they blur, something interesting happens to your understanding of reality. It becomes less about isolated things and more about relationships, less about solid objects and more about processes, less about fixed identities and more about continuous change. This shift is subtle, but it challenges one of the most basic assumptions you carry. that the world is made of clearly defined, separate pieces. Instead, it suggests that what you perceive as separate may actually be deeply connected, with boundaries that are not absolute but approximate. And once you start to see that, even your own sense of being a distinct, unchanging entity begins to feel less certain and more like something that is constantly being formed and reformed moment by moment. At some point, without noticing exactly when, you began to filter your questions. Not all at once, gradually. As a child, almost any question felt worth asking. It didn't matter if it sounded strange or didn't lead anywhere practical. You could wonder about anything: why shadows move, why time feels slow sometimes and fast at others, what happens inside things you can't see. There was no internal system telling you which questions were acceptable and which were not. But over time, that system formed. You started to sense which questions had clear answers and which ones didn't, which ones would be rewarded, and which ones would be ignored or brushed aside. And without anyone needing to explicitly tell you, you adjusted. You began to prefer questions that could be finished, questions with defined answers, clear explanations, and predictable outcomes. The kind you could resolve, store, and move past, and slowly you let go of the rest, not because they were unimportant, but because they didn't fit into the structure you were learning to operate within. Questions like, what is time really? Not how we measure it, but what it is. Or why does anything exist at all? Not how things behave, but why there is something rather than nothing. Or even simpler ones, what is a thing? Where does it truly begin and end? These questions don't have clean answers. You can approach them scientifically, philosophically, mathematically, but at some point each path reaches a limit. You find models, descriptions, theories. But the deeper why remains open. And because it remains open, it becomes uncomfortable. There's a kind of tension in holding a question without resolution. The mind looks for closure, something stable to rest on. When that doesn't come, the easiest option is to step away. So you learn quietly to avoid those edges. You stay within the areas where answers exist, where understanding feels achievable. You build confidence in what you know, and you rely on it. This is practical. It allows you to function, to learn efficiently, to communicate clearly. But it also narrows the range of your curiosity. Because the most fundamental questions, the ones that push against the limits of knowledge, are exactly the ones that resist closure. Science itself encounters this constantly. You can describe how time behaves in different conditions. You can measure it with extreme precision. You can even show that it flows differently depending on speed and gravity. But if you ask what time is in its deepest sense, there is no single, complete answer. You can explain how particles interact, how forces operate, how energy moves and transforms. But if you ask why the laws of physics are the way they are, why these patterns exist instead of others, the answer becomes uncertain. And this is not because we haven't tried hard enough. It's because there may be limits to the kind of answers we can form. As a child, encountering a question without an answer didn't necessarily stop you. You could stay with it. Let it remain open. Let it sit in the background of your thinking without needing to resolve it immediately. But as you grew older, you began to associate understanding with completion. To understand something meant to finish it, to reach the end of the question. And if a question had no clear end, it started to feel less useful. So you filtered it out. You focused on what could be known, measured, tested. And you left behind what could only be explored. But those unanswered questions didn't disappear. They're still there, just outside the usual path of your attention. And occasionally they resurface in quiet moments, in unexpected thoughts, in a brief pause where something familiar suddenly feels unfamiliar again. And when that happens, there's a choice. To move past it quickly, returning to the comfort of known explanations, or to stay with it a little longer, to allow the question to exist without rushing to close it. And in that small decision, something begins to shift, because the act of not filtering, of allowing even the unresolved questions to remain, starts to reopen a way of seeing that was never actually lost, just set aside. If you follow this path all the way through, if you keep looking, keep questioning, and resist the urge to settle too quickly, something unusual begins to happen. The world doesn't become clearer in the way you might expect, it becomes deeper. Not more complicated for the sake of confusion, but more layered, more open, less final. Things you once thought were completely understood begin to feel partial, not wrong, just incomplete. A simple object is no longer just an object. It becomes a doorway into multiple levels of description. At one level, it's something you can use. At another, it's a structure of molecules. At another, a network of atoms. Deeper still, a set of interactions between fields and forces. None of these levels cancel the others. They coexist, and that changes how you relate to what you see. Instead of asking, "What is this?" in a way that expects a single answer, you start to recognize that every answer depends on the level you're looking from. At the human scale, things are solid, stable, and separate. At the microscopic scale, they are mostly empty space with particles interacting across distances. At deeper levels, even the idea of particles becomes less clear, replaced by patterns and probabilities. So what is the object really? It doesn't have a single, final identity. It has multiple valid descriptions, each useful in its own context. And this realization does something subtle to your thinking. It weakens the need for absolute answers. You begin to see that understanding is not about reaching a final, fixed explanation. It's about building models that work within certain limits while remaining aware that those limits exist. This is how science actually operates at its best, not as a collection of ultimate truths, but as a constantly evolving set of approximations, each one more precise, more predictive, but never completely final. And when you see it this way, something interesting happens to the idea of certainty. It becomes less rigid. You can know something very well, use it, rely on it, trust its predictions, while still recognizing that it may not be the deepest possible description. This is not a weakness. It's a kind of intellectual honesty. And it brings you closer to the way reality seems to behave, because at every level we've explored, there is always another layer beneath. Another question that opens as soon as the previous one feels settled. Another boundary where understanding transitions into uncertainty. As a child, this endless depth would not have felt like a problem. It would have felt like an invitation, a reason to keep exploring, to keep asking, without needing to arrive at a final answer. But as an adult, there's often a desire to reach the bottom, to find the ultimate explanation that closes everything. And so far, that bottom has not appeared. Every time we think we're close, a deeper structure reveals itself. Every time we feel we've simplified the picture, new complexities emerge. And instead of seeing this as failure, it can be seen differently. It can be seen as a sign that reality is not something that fits neatly into a single, complete story. It's something that can be approached from many angles, described in many ways, but never fully captured by any one of them. And once you accept that, even slightly, the way you see everything begins to shift. You stop looking for the final answer that ends all questions. And you start noticing the richness in the fact the questions don't end. That every explanation is part of a larger structure. And every piece of understanding connects to something deeper. At that point, curiosity changes. It's no longer driven by the need to finish. It's driven by the recognition that there may be no final finish at all. And instead of making the world feel uncertain in a negative way, this can make it feel unexpectedly alive, because it means there is always more to see, more to question, and more to understand, no matter how far you've already gone. As you continue along this path, you begin to notice a pattern that extends beyond objects, particles, or even forces. It applies to how you think, how you interpret, and how you relate to knowledge itself. What you once assumed was solid and complete begins to reveal its provisional nature. Even the most confident explanations carry hidden boundaries. Every model you trust, every law you rely on works within limits. They are powerful, predictive, reliable, but they are not the ultimate truth. They are descriptions that fit within the constraints of observation and measurement. Take something as familiar as gravity. For centuries, humans observed objects falling, and Newton described it with precision. His equations allowed us to predict how planets move, how objects accelerate, and how tides behave. But Newton's laws didn't explain why gravity exists in the first place. Later, Einstein provided a deeper framework. describing gravity as the curvature of space-time. That model explains phenomena Newton couldn't, yet it too doesn't answer the fundamental question of why the universe has the properties that allow space-time to curve as it does. Every layer of understanding leads to another, deeper question. This pattern is not limited to physics. It appears wherever humans attempt to explain anything deeply. Life itself follows the same structure. Biological processes can be described in terms of chemistry, chemistry in terms of physics, and physics in terms of fundamental interactions. Yet at each step our explanations rely on assumptions, approximations, and models. None of them fully capture what life or matter actually is in an ultimate sense. What we know is incredibly precise and useful, yet simultaneously incomplete. As a child, this incompleteness wouldn't have been intimidating. You could sit with a mystery, explore it playfully, and remain fully engaged without needing closure. But as adults, we learn to equate understanding with resolution. We seek neat, final answers because they feel safe, comfortable, and efficient. Uncertainty becomes something to avoid rather than a space to explore. This shift shapes the way we experience knowledge, subtly limiting the range of questions we ask and the depth of curiosity we maintain. Science itself mirrors this duality. It thrives on uncertainty and incomplete understanding. Experiments are designed to probe the edges of the unknown, to challenge assumptions, and to reveal inconsistencies in our models. The moment a theory appears complete is the moment it becomes obsolete or needs revision. The beauty of scientific inquiry is that it embraces incompleteness, using it as a guide rather than a failure. It acknowledges that the universe is deeper than our current understanding and that each answer is provisional, a stepping stone rather than a destination. Recognizing this allows a shift in perspective. Instead of viewing knowledge as a set of fixed truths, you start seeing it as a dynamic, evolving process. Each explanation is valuable not because it is ultimate, but because it opens the door to further exploration. The universe at every level resists finality. What seems settled is only temporarily understood, and what appears simple is often underpinned by complex, subtle interactions that we are just beginning to grasp. Accepting this changes how you relate to learning, observation, and curiosity itself. It encourages patience, attention, and a willingness to dwell in the open spaces between what is known and what is yet to be discovered. The deeper implication is profound. Reality is not a static set of objects and laws. It is a living network of interactions, processes, and relationships. The closer you look, the more the boundaries blur, the more the familiar becomes strange, and the more questions multiply. This perspective transforms the way you engage with the world. Instead of seeking closure, you learn to embrace the infinite landscape of inquiry, finding wonder not in final answers, but in the endless possibilities that lie between understanding and mystery. By the time you reach this stage, a subtle realization begins to take shape. The world you experience is an ongoing collaboration between reality and your perception. Every sensation, every observation, every thought is filtered, interpreted, and reconstructed by your mind. What you perceive as concrete, stable, and immediate is only one layer of a much deeper, more intricate reality. Your senses do not transmit raw information. They provide signals that your brain organizes into a coherent narrative. You never experience reality directly. You experience a model of it that your brain has created. This model is incredibly effective. It allows you to act, navigate, and survive. It allows you to recognize patterns, predict outcomes, and interact with objects and people efficiently. But efficiency comes at a cost. To create a manageable representation of the world, the brain simplifies, smooths, and fills in gaps. It produces continuity where there may be none, solidity where there is mostly empty space, and separation where interactions are continuous. The table you see, the floor beneath your feet, even your own body, all appear stable and fixed, but under the surface they are dynamic processes interacting in a vast network of particles, fields, and forces. As a child, you were less constrained by these mental models. You could explore without expectation, observe without immediately categorizing, and remain open to the strangeness of ordinary things. When you dropped a spoon, tilted a glass, or stared at sunlight through a prism, You weren't seeking closure. You were dwelling inside the question itself. There was no urgency to resolve it. The world was full of endless, wise, and that uncertainty was not threatening, it was exhilarating. Every experience carried the potential to reveal something new. Over time, you learn to close questions quickly. School's social conditioning and practical life reward efficiency. If you can identify, label, and explain something, you are rewarded with a sense of competence and progress. The curiosity that once allowed you to dwell on subtle, strange phenomena is gradually replaced with recognition, categorization, and the pursuit of predictable outcomes. This is functional. It allows you to operate in a complex world, but it also limits perception. Familiarity becomes a filter that prevents you from seeing what is really there. You experience the expected rather than the actual, and the ordinary is rarely examined closely enough to reveal its deeper complexity. At the most fundamental level, the universe is not made of discrete, solid objects, but of interactions, processes, and relationships. Touch is not contact, it is the electromagnetic repulsion of electron clouds. A body is not a fixed entity, it is a continuously changing collection of particles exchanging matter and energy with the environment. Boundaries are gradients, not sharp lines. Even particles themselves behave in ways that resist intuitive understanding, sometimes acting as waves, sometimes as localized points. What seems separate is deeply connected. What seems static is in constant flux. Recognizing this does more than expand understanding. It transforms perception. The familiar becomes strange, the obvious becomes subtle, and everyday experiences gain layers of depth. Your relationship with knowledge, observation, and curiosity shifts. Understanding is no longer a race to closure, but a process of exploration. You learn to dwell in questions, to follow the open spaces where certainty fades, and to accept that reality may never be fully captured by a single explanation. This perspective carries a quiet philosophical truth grounded in science. Reality is not a set of objects to be fully understood and contained. It is a dynamic, evolving web of interactions constantly revealing deeper levels of complexity. The childlike wonder you once had was not naive. It was closer to the truth of how the universe operates. To regain even a fraction of that openness is to see the world in a way that is both scientifically honest and profoundly alive, where curiosity, attention, and observation are not about reaching the end of understanding, but about engaging fully with the endless unfolding of reality itself.